Good morning, myself Rohit from third year AML branch, and here we are presenting our artificial intelligence assignment one, and our problem statement is evaluate and propose improvements in pathfinding algorithm. It's difference between a star search versus greedy best first search, and our team is guided by Shilpa RN, ma'am. Next slide. And our team members are Sahil GK, Rohan DR, and Rohit T, myself, and Shivkumar BC. An introduction. Here, pathfinding algorithms are core concept of artificial intelligence and robotics that determine the optical path between the two nodes in graphs. And these algorithms are very crucial in navigation systems and robotics like game AI and logistics. Here, both A star and greedy based search algorithms belong to a family of informed search algorithms, which uses the heuristic functions to guide the search towards the goal efficiently. And A star and the greedy based first search are heuristic based search algorithm. And our goal is to evaluate their efficiency, heuristic impact, and propose improvements. Yes. And our main objective is to understand and explaining the working principle of an A star and a greedy best first algorithms to compare both algorithms in terms of time complexity and space complexity and path efficiency, and to analyze the heuristic functions determining algorithm performance, to identify the practical applications where these algorithms would perform best, and our innovative improvements for enhancing the scalability and speed and accuracy of pathfinding algorithms, and evaluate the hybrid or adaptive techniques can improve real world pathfinding performance using these algorithms. The next slide. Working principle of an A star search. Here it combines the uniform cost search and greedy search evaluation function. This is the function of an A star search. Fn equals gn plus hn, where gn is an actual cost from the start node to the current node, and hn is a heuristic estimation of the cost from the current node to the goal, and fn stands for estimated total cost of an path through node n. And the further presentation is explained by my teammate Rohan. Start.
So good. Yes. So hello, I am Rohan here. So this is the working principle of greedy first search. Focuses only on heuristic value. The algorithm only looks at how close and a node seem to a goal. It doesn't care about the total cost so far. It uses heuristic function h of n. The steps start from the beginning node. Pick the node that has the smallest heuristic value. Expand the node. Keep doing this until you reach the goal or run out of the nodes. So next slide. So this is the performance comparison. So these are the aspects. This is the A star algorithm. This is the greedy BFS evaluation function. A star uses f of n is equal to g of n plus h of n, both actual cost of g of n and estimated cost h of n. Greedy BFS only uses h of n, just the estimated distance to the goal, and the optimal solution. Yes, always finds the best path. No, greedy BFS no may find the shortest looking but wrong path. Time complexity. A star slower and checks more nodes. Greedy BFS faster and checks fewer nodes. And the space complexity in A star needs more memory. In greedy BFS needs the less memory. And next speed. It is moderate, and in greedy BFS it is fast. In path quality, in A star it is optimal, and in greedy BFS it is approximate, not always the best. Next slide. So this is the impact of heuristic functions. Heuristic estimates the distance to goal. A heuristic gives the guess of how far a node is from the goal. These are the common heuristics. Manhattan distance. The distance measured by moving only straight grid lines. Euclidean distance, the direct as the crow flies distance between 2 points. Chebyshev distance, the distance based on the largest difference between coordinates, and the impacts on A star. A stronger heuristic reduces search space drastically. A good heuristic helps A star search fewer paths and find the goal faster. For example, using a man at distance, explore a fewer nodes that one using uniform cost. And in impact of greedy BFS. Greedy BFS performance depends slowly on the heuristic. It explains the algorithm success completely relies on how good the heuristic is. A poor heuristic leads to wrong direction and longer search times. It means if heuristic is bad, the algorithm can go with the wrong way and take a longer to finish. The third point, in dynamic environment, adaptation improves efficiency, which means if condition changes, updating the heuristic values can make the search faster and more accurate. Next slide is explained by Sahil.
Thank you, Rohan.
Mhm.
This slide shows how different pathfinding algorithms are used in the real life. The A star ಏನೈತ್ಲೆ
Mhm.
This slide shows how different pathfinding algorithms are used in the real life. The A star algorithm is the top choice for the GPS navigation, video games, and robot navigation because it's good at finding the best and the smoothest paths. It is highly efficient and reliable. And on the other hand, the greedy brush first search is used for web crawlers and the search engines because it prioritizes speed and quickly finds a solution, which is more important for those applications. And in the next slide, proposed improvements. Introduces weight and heuristic, which is the formula of f of n is equal to g of n plus w star h of n, adaptive a star, which updates the heuristic dynamical based on the different environments. And the next point is bidirectional A star. Run searches from the both start and the goal. Hierarchical A star. Cluster large map for faster computation. Learning based heuristics here, which uses the AI model to predict HFN intelligently. And improvements in greedy best for search. Adaptive heuristic updating. This lets the algorithm adjust its strategy to avoid getting stuck in the dead end. A hybrid A star GBFS algorithm. This combines the best part of both A star and BFS to get a fast and accurate result. Multi-resolution research. This start with a broad view and then focuses on the details, which is useful for large areas. Anytime ready search. This finds a quick solution. And the last slide is conclusion. This slide summarizes the main points. It highlights the both A and greedy BFS are powerful algorithm. A star is perfect for finding the most optimal and complete path, while a greedy BFS is a great choice when speed and low memory usage are the top priorities. The future of these algorithms depends on the mix of both and situation efficiently. Thank you. ಮಾಡ ಮಾಡ
Okay, now let's go to the code. Here from queue import priority queue. Here it imports a Python's priority queue class, and here it used an open set sorted by priority f value and def a star graph star goal heuristic as the arguments. Here define a function a star that takes graph star goal heuristic and PQ equals priority queue. Here it creates a priority queue used to pick the next node to the expand. And at line number 4, PQ dot put 0 comma start. Here it inserts the start node with priority 0 and came from equals start none. The dictionary to reconstruct the path once the goal is reached. And G score equals node float INF for node in graph. Here it initialize G score the unknown cost from the start to each node. And if current equals goal, here if we pop the goal node, we have the path to reconstruct it. And the path is a empty list to reconstruct the path. And path dot append current, here append each node while walking back, and came from current means move to the parent node. And for neighbor cost in graph current dot items, it iterates over neighbors of current. This assumes graph current is a dict mapping neighbor. And as we go on to the next line, here heuristic neighbor, here it computes equals G plus H for a neighbor. And return none. If the loop ends without finding the goal, it returns the none. And as we go to the greedy best first line, as in line number 1, from queue import priority guy. Again, as I said, it imports the Python's priority queue. And def greedy BFS and graph start as same as the arguments. It defines the greedy best search function parameter similar to A star search. Here P equals priority queue to select next node by heuristic value. And PQ dot put is used to insert the start with priority, and came from here same path reconstruction visited equals here set. It tracks nodes already expanded to re-expanding. And as we say, go on to the next line, here visited, if a neighbor not yet expanded, it considered it and expanded. And PQ dot put heuristic neighbor, it pushes neighbor with priority equal to heuristic only. Return none. Here if the none path is found, it returns no path found. And as you see the example, 3D BFS path ABC, greedy BFS always picks the node that looks closest to the goal by heuristic alone. It is fast and but it is not optimal. It can return a longer path or even fall. So this was our code and the result. And thank you for giving this opportunity to completing this assignment. Thank you, Shilbamam. Thank you, teammates.